All right, let's talk through the Module 3 homework together. So problem number 1 says a local fundraising group plans to rent an all-inclusive space for their event. In addition to the rental space cost, the location charged $18 per person for dinner. So this is just that same rate that we had from our problem, or from I guess it was from the Module 2 homework. Sorry, my brain is just fuzzy. Let's let N represent the number of people who will attend and C represent the total cost of the event. All right, so we know that rate. And then in part A, it says, you know that the cost for 200 people to attend is $7,100. So this is kind of like my reference point. All right, so that's going to be important. It says, use this information with the constant rate of change to determine the cost for the following number of people attending. So either use a table or graph to illustrate. So I'm just going to use a table. So I'm going to organize this. Let's say N, I guess I'll use these variables here, N and C. So if I make this, oh, I'm just going to get so messy so quick. So N and C. So I'm going to first put in what we know, and then I'm going to do 305 here. So my first step is I want to find the change in the number of people. So that's step 1. So I'm going to do 305 minus 200, and I'm going to get 105. By the way, this table in part B is the same thing. It's just kind of organizing it differently. So I'm going to copy my work as I go. So the change in the number of people from 200 for 305, so that's just going to be 305 minus 200. Also, I'm going to get 105. All right, so then I'm going to, my second step is going to be to find to use the constant rate of change to find my change in cost. So I'm going to do 105 people times the rate of $18 per person, and I'm going to get an increase. I guess I'll write it like that. It's going to be an increase of $1,890. So that's what I'm going to do here. I'm going to do my rate times my change in number of people, and I'm going to get 1890. And then my final step is going to be, as I'm going to take that 7,100, I'm going to add my cost of 1890. I'm going to get total cost now of 8990. So if I take the cost I knew, the $7,100 we already knew, my cost went up by 1890. Now my total cost is 8990. All right, I'm going to do that same thing for all 3 of these. I guess I'll just make my table for all 3 now. So here N, C, I'm going to do my 200, my 7,100. This one is asking for 451 people. Like I said, I'm going to be efficient. So 200, 7,100, and now this is for 174. All right, so again, I'm going to do the same thing. I knew with 200 people coming, the cost was 7,100. Oh, we have more people coming, so let's find out how many more people. So 451 minus 200 is 251, so 451 minus 200. So 251 more people are coming. The question is, how much is that going to cost me? Well, it's $18 per person times 251 people is going to increase my cost by 45.18. So $18 per person, 251 more people, an increase of $4,518. And then my final step is that I'm going to take, I already knew it was $7,100. Now my cost is going to go up by 45.18. So I'm going to add those, and I'm going to get a total of 11,618. So my 7,100 plus the 45.18, and I'm going to get 11,618. I'm going to do the same thing for this last problem, but now my number of people is going down, right? We have less people coming, so I would do 174 minus 200. I get negative 26. But again, I need to take that. So at $18 per person, we've lost 26 people. And so we are going to pay $468 less. So I'll write this here as well. And then that means if I take those 7,100, we decrease by $468, we're going to get 6632. So I would take my 7,100. I could add or subtract. I guess I'll add a negative 468. I know this is different than I wrote in the solution. Sorry. I'm going to get 6632. All right, so in terms of my process, right, the first thing we did was find the change in the number of people. The second thing we did is we took that change in number of people, multiplied it by our rate to find out what our change in cost was. And then the third step is we took that change in cost and we added it to our reference cost. So if I take that process and I put it in a formula, so if I want to find my total cost, right, we said the first thing we did is we found our change in the number of people, right? So that's kind of what we did there. Then from there, our next step was we took that and we multiplied it by the constant rate of change. And then finally, what we did is we took that and we added it to the 7,100. And so that really is this formula that inputs the number of people attending and it's going to output my cost. So for example, if I wanted to find out what the cost was for 350 people, right, we could simply input that here, right, because this is representing, this is representing my change in number of people. When I multiply it by my rate, this is going to be my change in cost. When I add it to my reference cost, that's going to give me my new cost, which is going to be $9,800. Oh, look at my color coding. Okay, let's keep going. So number 2 says, suppose there's an amount of water in the tank and that the height of the water was draining at a constant rate of 2.5 centimeters per minute. So that means that my crock is negative 2.5 centimeters per minute because as time is increasing, the height is going down. All right, and then we also know that at 3.6 minutes, the height of the water is 25.5 centimeters. So I could even write it as a reference point. So in order to describe my process, the first thing I need to do is I need to find the change in time from the 3.6 minutes to the new one they're asking for, which is 9.7 minutes. Right, second step would be to multiply the change in time, by the crock to find the change in height. And then my first step would be to add the change in height to the reference height. Height. Sorry, that was terrible. So those are kind of like my 3 steps. So if you want to work it out, you can, but that's really the process. So if I were to kind of explain that as a general process, the first step is always going to be to find my change in time from 3.6 minutes. And so that's how we represent that. We're going to take that change in time, we're going to multiply it by my constant rate, which is negative 2.5. So now this piece represents my change in height. And then we're going to add it to our reference height. Again, it's just going to kind of work the same way each time. So for question 3, same thing. So we're given this as our reference point. M is my output, is decreasing at a constant rate of 9.3. So my crock is negative 9.3 with respect to the input, and my input is actually P. So write a function so that determines M with respect to P. So even if I didn't tell you the first part, M with respect to P is telling you M is my output, and then P is my input. So I should write a formula with M equals, because M is always going to be my output here. So I'm just going to kind of use that same kind of like setup like we've been doing. So my crock is negative 9.3, P is my input, so P minus my reference input plus my reference output. And then you might not think of it that way, you might think of it like this, right? And so I don't really care which way you do it. Probably this way is the way that we tend to think of it more, but it really doesn't matter. All right, problem number 4 says, suppose a candle burns such that its length decreases at a constant rate of 1.6 inches every hour. That is, the rate of change is negative 1.6 inches per hour. After 3.5 hours of burning, the length of the candle is 9.9 inches. So we want to use that with the constant rate to find our missing values in the table. So I'm just going to kind of go through step by step. So let's say we first want to start by finding the length of the candle at 1.8 hours. So first step is I'm going to find the change in time. So if I do 1.8 minus 3.5, I'm going to get negative 1.7 hours. right? So it's 1.7 hours earlier. So I want to know how would the length of my candle change? So my step 2 would be to do my rate times my change in time, and I'm going to get 2.72. So 1.7 hours earlier, our candle was 2.72 inches longer, right? That should make sense. Earlier in time, I should have a larger candle length. So if I do 9.9 plus 2.72, I'm going to get a length of 12.62 inches. That's my answer in there. All right, that's kind of like my step 3. All right, we can do the same idea to get this next one. So if I go from 3.5 hours to 7, so I guess I'll just keep on going up. So I would do 7 minus 3.5. That is an increase of 3.5 hours. So my next step is to find out in that 3.5 hours, how did the length of my candle change? So negative 1.6 inches per hour times 3.5 hours is going to decrease by 5.6. Oops, no, yeah, we're good. Oh, sorry. You guys, I can't count. This should be a 5. All right, we're going to decrease by 5.6 inches. So in 3.5 hours, our length is decreased by 5.6 inches. So it was 9.9. It's gone down 5.6. And so we have, now it's 4.3 inches. All right, let's keep on going. By the way, that was step 6. We'll pretend like I can count. All right, so step 7. Now I can go back from my 3.5, or I can just kind of work from the closest table value I have. So I could do 9.2 minus 7. That's going to be an increase of 2.2 hours. So then I say, okay, well, going down 1.6 inches per hour times 2.2 hours, that's going to be a decrease of 3.52, 52 inches. So it was at 4.3, we went down 3.52 inches. So now my candle length is 0.78 inches. It's almost done. All right, that's my step 9. All right, this last one is the same idea, but we're kind of working backwards. Now we know the length of the candle, we want to know the time. So my first step here, so this is my step 10, I guess, is I would find the change in height. So I would just do 0 minus 7 or minus 0.78, and we get a change in height because all these kind of represent changes in height. We get a change in height of negative 0.78 inches. Right, all these represent changes in time. So then my next step would say, okay, well, how long did it take to decrease by 0.78 inches? So to find that, now instead of multiplying by the rate, we divide by the rate. So negative 0.78 divided by negative 1.6, we're going to get, 0.4875 hours. So that last little bit takes us 0.4875 hours. We were already at 9.2 hours, so I'm going to add that. I don't know where I'm going to fit this. 4875. So that's my step 12. And when we do that, we get 9.6875 hours. Whew, that was a lot of stuff. All right, finally, we can write our formula. We know, again, that our crock is negative 1.6 inches per hour. We had our reference point of 3.5. At this point, I could use any of my points, but just to be certain. So then I could write the formula like we've been doing. So negative 1.6 inches per hour times the change in time from 3.5 hours, add it to our reference length. So this is representing how my time changes from 3.5 hours. This is representing the corresponding change in length from the reference length. And that's it.